Okay, we're looking at two problems dealing with particle motion again. And in the first one, it's a little bit different than the second, but we'll look at them separately. It says the position of a body moving on a coordinate line is given by s equals t squared minus 5t plus 3, with s in meters and t in seconds. When, if ever, during the interval from 0 to 5, does the body change direction? So, how would we know that? Well, we'd know that it would change direction if the sign of the velocity would change. So, what we first need to do is we first need to figure out, well, what is the velocity function? So, if s equals t squared minus 5t plus 3, then s prime is 2t minus 5. We take the derivative. This is the velocity function. Okay, now what I'm going to do is I'm actually going to graph that, because if I graph that, all right, I'll be able to see it very clearly. So let me just make a little grid real quick. Okay, so let's say that it crosses down here at -5, right there. -5, a point right there, and then it crosses the axis somewhere right in between here. If you use the rise over the run, up 2 over 1, up 2, so up 1, up 2 over 1, up 1, up 2 over 1, something like that. So let's just pretend that it crosses right through there. The graph is, of course, not drawn to scale, all right? But notice what happens if this is the graph of the velocity, okay? The velocity is positive above the axis, and it is negative below the axis, okay? So this is the graph of the velocity versus time, all right? So where does it change direction? Right there at that point, okay? And in order to figure that out, all you have to do is take your 2t minus 5 and you set it equal to 0. So we get 2t equals 5, and we divide both sides by 2. It happens at 5 over 2 seconds, which is 2.5. So we can say that it changes direction at t equals 2.5 seconds. All right, so that's where it happens. All right, that's the first problem for particle motion. Now let's take a look at another problem. Just draw a little dividing line here. All right, in the second example, they say at the time t, the position of a body is moving along the s-axis where s is equal to t cubed minus 21t squared plus 120t meters. It says find the body's acceleration each time the velocity is 0. So what are we going to have to do? First, we have to find s prime of t, which is the velocity function. And once we find the velocity function, we're going to set it equal to 0 and figure out those 2 time values, or 3 time values. There's 2 actually. And then we're going to plug that into the second derivative of the position function, which is the acceleration function. So it's kind of a combination problem here. First derivative, the velocity is 3t squared minus 42t plus 120. Okay, so this one right here, we're going to have to set equal to 0 because this is where the velocity equals 0. So I'm going to factor out the 3 because it's the greatest common factor. It's going to leave me with t squared minus 14t plus 40. All right, and now this right here, I'm going to go ahead and I'm going to factor, set it equal to 0, and I'm going to factor it out. Factors of 40 that add to give me negative 14. Well, that's not too difficult. That is negative 10. Oops. 1 second there. I'm messing with my pen here. That is negative 10 and negative 4. So it looks something like that. All right. So I get a time t equals 10 and a time t equals 4. This is where my velocity is 0. But now they want us to find the acceleration when the velocity is 0. So what we're going to have to do is we're going to have to take the derivative one more time. We have a of t, which is s double prime of t, which is v prime of t, which is the first derivative of the velocity function, or the second derivative of the position function. And so we're going to get 6t minus 42. 6t minus 42. And so to find the acceleration, we're going to plug in 4 into 6t minus 42, the acceleration function. 6 times 4 minus 42 equals 24 minus 42, which is negative 18 meters per second squared. So that's the first one. That's the first acceleration. And then let's check the second one. A of 10, 6 times 10 minus 42, which is 60 minus 42, which is a positive 18 meters per second squared. So that right there, it's decelerating, and here it's accelerating. Okay, so just, something to consider, that at one point, it's slowing down, and at another point it's probably speeding up. Okay, but otherwise some really good applications here if we look at them for particle motion and how we apply derivatives to those things. So as always, I hope this video was helpful, and remember, like and subscribe.